Yeah, we'll be looking at the fundamental ideas of differential calculus. Okay, um, let's look at this function y is equal to f of x. Okay, uh, letter y is can also be written as what? F of x. Okay, and what does that mean? This means that y is a function of x. Okay, there are other letters we can use to distinguish between functions. We can use uh, uh, this, we can use something like this to distinguish between functions. We can use something like this also to distinguish between functions. Okay, uh, that's that. Let's look at the applications of this y as a function of x. Okay, the meaning of this statement y as a function of x is this. It means that y is written in form of what? In form of x expression. Okay, look at this one now. F of x is equal to what? It's this. You can see the letter z is what? Is all x. Okay, so if you are looking for f of 2, for example, f of 2, the meaning is this, that x is 2, okay, and then you plug in those values, okay. Don't forget that your f of x is this, x squared minus 3x. So f of 2 means x is 2. Wherever you see x, plug in those values, and that will be equal to 2 squared minus what? 3 times 2, okay, and that will be equal to 4 minus 6. That's minus 2. The f of 3, the same thing you do. That means x is what? X is 3. So that will be 3 squared. You just plug in the given expression, minus 3 times 3. And that's 9 minus 3 times 3 is 9. That's 0. F of minus 5, you do likewise. Okay? I told you that that will be minus 5 squared minus 3 times minus 5. And that will be equal to 25. Minus times minus, that's a plus 15. And that's 40. Of a is equal to a squared minus 3 times a. That's so that's that on functions. Okay. If you have something of this nature, okay, maybe 5x3 minus 10x squared minus 8, it means that this function is this is a function of what? It's a function of x. That means the expression is written in the form of x. Okay. Let's take more questions on functions. We have the function this equal to what? This expression. Then we are told to evaluate far of 0, which means x is 0. Then you substitute in this expression. That will give you 6. Okay. What of f of 1? What of this of 1? That means x is 1. Then you put it there. You have 1 squared minus 5 times 1 plus 6. Okay. And that will give us 1 minus 5 minus 4 plus 6. And that's 2. Okay. Then the next question, for what values of x is this function equal to 0? So if the function is equal to 0, then it means that the third one, we have 0 equal to what? S squared minus 5x plus 6. Okay. And that will give us what? That will give us factors of 6 is 3. Okay, how can we use 3 and 2? And then, can 3 and 2 give us minus 5? Yes, minus 3, minus 2. Okay, and when you multiply minus 2 times minus 3, you're going to have a plus 6. So x is equal to what? X is equal to 3 or 2. So that's the value of x for which the function is equal to 0. So that's that on this particular aspect. So change of function, the rate of change of functions, okay, which we call the gradients. Okay, if you have 2 points, x1, x2, okay, you also have y1, y2, that is x1, y1 as a coordinate 1. As x is increasing, y also is also increasing. You also have another coordinate, x2, y2. As s2 is also increasing, y2 is also increasing. So we can quickly get what we call the gradients. The gradients is called changing y over changing x, which is equal to y2 minus y1 over x2 minus x1. So that's a gradient. Okay, we can also use calculus, okay, to get the gradients. Okay, if your y is f of x, okay, f prime is also called gradients. Okay, but we'll get to that later. We'll get to that shortly. Okay, so that's that on gradients. Okay, that's that on gradients. Limits to get differentiation. Okay, the use of limits for differentiation. Okay, that's what we want to do in this aspect. And it has a formula: your dy dx, okay, or your f prime of x is equal to limits as h tends to 0 of f of h plus then minus f of x all over h. So that's that. Limits of f as x is changing minus the original function. Okay, this is f of x plus h over h as h tends to 0. Okay, the y dx is called derivative, or call it differential coefficients. Okay, differential coefficients. So once you want to see how we can use limits to get derivative of functions or differential coefficients of functions. Okay, let's see how we can apply this formula. Okay, example 1. Okay, of the y dx. Okay, equal to limits as h tends to 0. Your function is what? F of x is equal to 3x squared. Don't forget, f of x is the same thing as what? Y and f of x, they are the same thing. Okay? So, you start with you have 3. Okay? Then, anywhere you see x, you put what? X plus h there. That will be x plus h, then you square it. And then minus the original function, f of x, which is what? 3x squared all over h. Let me explain again. The function is this. The function is 3x squared. Okay? And the increments, it will be wherever you see x value, you write x plus h. Okay, then you square it. And f of x is the original function. Just put it there. Okay? So that's what we have now. Then the next thing to do is for us to do the expansion of this, which will be 3 into bracket x squared plus this one times this one times 2. 2 this, and then plus h squared. Okay, minus 3x squared all over h. Okay? Allow the 3 to come in. If you allow the 3 to come in, you have limits as h tends to 0 this one times this one, that's 3x squared, plus this one times this one, 6x, this one times the last one, plus x, then minus x all over h. So this and this will cancel out. Okay? Then you have limits as h tends to 0, h is there, h is here. You can take it out. That will be 6. You can take the h out. That will be 6x. Here, this one times this one, we have this, and this one times this one, that was to be 3. That's 3. That's the 3. Okay. So what is common between this one and this one is 3h. It's 3h. Let's just take the. You just want the h to go. So take the h here, take it out. So you have this all over h. So this h has cancelled. Okay. Then finally, you have limits as h tends to 0. You have 6x plus 3h. And then one thing about limit is that at your last point after the algebra is for you to just substitute, plug in h equal to 0 into this expression, and that will be equal to what? 6h plus what? 3 times 0, and that's 0. So your derivative or differential coefficients of that function is what? Is 6. 6. Okay? It's 6. If this is not clear, let me quickly recap it again. We were using limits to get derivative, okay? And this is the formula. You divide the x equal to what? It's written as f prime of x, okay? So what this means is very simple. Yeah, wherever you see the x function, just put h, x plus h, and that's what we did here. Instead of writing 3x squared, it will be 3 is a constant, okay? Isolate that, and then where this will be x plus h. That's our x now at the point at the increment. Okay, that's our h. Then you square it. Okay, minus f of x. That's the original function. Okay, all over h. Okay, and what this plus h means is that s is increasing by what? By h. That's the implication of that. Then after that, you do the algebra. Then you factorize and get the answer. Okay.